Thank you, Gunnar. Good morning, everybody. As I think Gunnar said, I've got to say my Danish isn't brilliant, but I think Gunnar's explained I'm Chief Executive of RIBA Enterprises, and I'm an absolute fan of BIM. Apologies, I'm going to wander around the stage quite a bit, so I'm not very good at sitting still. So, building information modelling, it's all about the information, and the title of this presentation refers to a concept in physics. It's all about irresistible force meets immovable object. What happens if a force that cannot be stopped comes across something that cannot be moved? Some people think the construction industry is an industry that cannot be moved. It's done the same thing for years. But we've got a movement in BIM which I think is capable of transforming an industry. I'm going to talk to you about that, not just about technology, but technology is key to it, but about people and about culture, because that's really what we've got to change. So in the presentation, I'm going to give you a little bit about us, about NBS and RIBA Enterprises, who we are and what we do. We'll talk a little bit about fear and things that worry me, as well as where the government is going in the UK and driving our industry, what BIM really is and what we should be looking for in BIM, and then how we use this as competitive advantage. Then a little bit about what happens next. And what that really means is, with fear, the issues that we face and how we deal with those, why and how the government is actually moving things forward, that it's more than just geometry. BIM isn't just about geometry, that's 3D CAD. BIM is about information, it's that I in the middle of BIM. And we're going to talk about how designers can win this race to actually delivering high quality information. And then actually, it's already here. BIM is around us now. So a little bit about us first. NBS and RIBA Enterprises. My job title is Chief Executive of RIBA Enterprises. But a lot of the work I do is actually with our NBS brand. So RIBA Enterprises first. We are wholly owned by the Royal Institute of British Architects. The RIBA has been around for nearly 180 years. NBS has been around for about 40 years. That was part of another group of companies that came together to become RIBA Enterprises. All of the profits that we deliver go back to the RIBA, and they spend it on the good of the industry, on promoting the benefits of architecture in its wider context. So when it comes to things like corporate social responsibility, we give 100% of our profits to charity. That makes us feel very, very good. It also gives us a bit of a problem, because people think of us as just being run by the architects. Oh, you don't need to worry about them, they just do all the pretty stuff. Who's going to do all the real stuff about how we put buildings together? That's why we have two brands. So when we go into the market, we deliver things under the RIBA brand when we talk about architecture and the general public, and we use the NBS brand when we talk about the industry and across all of the sectors. Curiously, in our customer base, less than half of our customers are architects. We really are pan-industry in the things that we deliver. And if we look at the products under those two headings, what we'll find on the right-hand side are lots of things to do with architects, learning, continuing professional development, the RIBA journal and other journals. We have research journals that will do more in that area. And the bookshop and publishing. We publish the UK building regulations. So lots of things to do with architects. But under the NBS side, we've got three main streams. We've got the specification. NBS is National Building Specification. We've also got lots of product information, including the latest National BIM Library, and then knowledge management, knowledge and information management, and the Construction Information Service. You're going to see how all of those fit together a little bit later. But if you look at NBS, as I say, it was first published over 40 years ago, 1973. It was in book form originally, but this, believe it or not, was the first BIM tool. 40 years ago we've been doing BIM. I can prove it to you, because on the inside cover, we've got this drawing. I hope you can see that. This tells you all about how you put the different types of information together. how you link them together. So we've got drawings and specification, we've got cost data, we've got product information, all linked together back in 1973. Fantastic, we just didn't realise what we'd done. And the reason this came about was because in the 1960s, there was a big survey of the industry. We're very, very good at doing surveys and finding out what's wrong. We're not particularly good about doing anything with it. But what we found in the 1960s was the buildings we were building weren't very good quality. They weren't described very well. And what we needed was a system of information to bring all this different type of information together so that we can be more efficient and save money. Sounds familiar, doesn't it? So MBS was born and brought all of this type of information together, and it was a disaster. The business nearly went bust. It was based in London originally, and the cost base was too high, and two of the directors at the time were from Newcastle in the north of England. They said we can save the business by reducing costs and moving up to the northeast. And we've been up in the northeast ever since. So I live just outside Newcastle, just south of what is going to become the national border between England and Scotland. Let's not talk about that one. So 40 years ago we had trouble because the industry wouldn't adopt it. It was a great idea, but we couldn't get the industry to change. So we struggled along, and eventually people started to realise this sounded like a good idea. And if we actually do things properly, things get better. Amazing, amazing. 40 years on, we're still talking about the same thing. We're talking about how to actually get the information from one part to another and reuse that information. How do we work together? How do we collaborate? And move into FM as well. For us, this is our bread and butter. This is what we do every single day. For us, BIM is brilliant. It's actually putting things into the world that we know best. So, what do I fear? What's the thing that keeps me awake at night? Well, the first one is I don't like dark. Really don't like dark, so that worries me. Recently, it's been about making sure you lot stay awake and you actually like what you hear, you think it's going to be valuable. I'm terrified of these things. Absolutely terrified of these things. And then the thing that really worries me is this. It is that irresistible force meets immovable object. How do we get the industry to change? Because change is coming. Whatever you think, you are going to be doing things differently in 10 years' time. We can see that through other industries. Just to give you an example of how things don't change, this is near me where I live. This is Hadrian's Wall in the north of England, the borderline between the two countries, Scotland and England. The Romans built it nearly 2,000 years ago. I feel sorry for the Roman centurions. They came from wonderful Rome, where it's blue sky, 30 degrees, and they came to the north of England where the rain comes horizontal. So they used really clever Italian engineering, and they built houses with underfloor heating and cavity walls. They put insulation into the rooms to make sure these homes stayed nice and warm and comfortable. Skip forward 2,000 years, and here's a British construction site where we have underfloor heating and cavity walls. And we put every brick, one single brick, on top of another. Even the scaffolding systems are essentially the same scaffolding systems. In 2,000 years, we have not changed. This is an immovable object. The industry isn't changing, it isn't adapting, and we have to do something about it. The times, as Bob says, they are a-changing. And for us, it's the change that we see every day. In your pockets, I'll guarantee you've got a lot of the music you've ever bought. It's no longer in a record set somewhere, hanging on it or sitting on a shelf. It's on an iPod or on your Samsung or whatever phone you happen to have. Anybody still got a VCR? No, you're probably streaming all of your movies online. Okay, that changes the way businesses work. What about books? Nowadays, you've got a whole library carried around with you in your Kindle. My wife is very traditional. She doesn't like digital things. Then I bought her a Kindle for Christmas. She's not bought a paper book since. These things are changing industries completely. So what about construction? How does construction change? Well, we've gone digital, haven't we? We're all using CAD. Yeah, but that's really just a digital drawing board. It's not a digital construction industry. We haven't seen the leap, the fundamental change in an industry that all of these other industries have. Construction is the last of the major industries to go through that huge shift, but it is coming. Kodak. Kodak was a $16 billion company in the United States. It was a chemical business. You'll think of them as a film business, but actually they were a chemicals business. They just put the chemicals onto photographic film, also photographic paper. They went from being a $16 billion company to being out of business in 10 years because their industry changed. What's the really scary fact about Kodak? They invented the digital camera. Amazing. They saw the technology, they understood what the technology could do. But unfortunately, they realized that that technology would undermine their core business, so they decided not to pursue it. Major mistake. Because that change was coming, the technology was changing anyway. What they needed to do was to recognize that for their business, because this change was going to take place, they had to go with it. They could have led the industry in digital photography, but instead they said, no, we don't want that, we want to protect our chemicals business. Bad move. But it's not just about technology change. Microsoft and Apple, both in the technology business, one performing far better than the other. So this chart shows you what happens if you invest $10,000 back in 2003, how much would you have now? Well, if you'd invest in Apple, you'd be very, very rich. If you invest in Microsoft, you'd have got a little bit more. What's the difference? Apple understood what their customers' expectations were, what the customers really wanted. They could apply the technology to meet their customers' needs. And as a result, they kept growing, they kept innovating, they grew their market position. So the lessons we need to learn from this are that technological change cannot be avoided. It is going to happen. But we have to do it with our customers. We have to understand what they expect and support their progress as well. So, on to the government and what's going on in the UK. We were a little bit backward. We're backward about all sorts of different things, but really not good at this BIM stuff. It's happening over in the States. So the government sent people over to the States to go and find out what was going on. And this chap, he's called Francis Maud, he runs our cabinet office. He said, do you know what, this is brilliant. This has the ability to transform our construction industry and maybe put the construction industry in the UK as a global leader. Most people laughed at that statement because the UK is not particularly good at construction. We've already seen it's been doing the same thing for 2,000 years, but he was determined. He set us on a path to deliver the best industry in the world. And we've done this before. But this is where we were. So, do you know who this is? This is the anthill mob from Wacky Races. This is our construction industry at the moment, the UK construction industry. It looks good. It's a nice car. All people in there heading in the same direction. So that's great too. We try to do the same thing, but the only way we get there is by pedaling like mad. It's very, very inefficient. So what Francis Maud was looking for was this. It's back to that Italian engineering again. Formula One racing team. Everybody on that team knows their job. They have one job to do, they do it extremely well. They're all trying to get the guy in the car around the track as quickly as possible. They can change 4 tyres and fill up that car with fuel in less time than it takes me to get out of my car. They are brilliant. They've understood the process and refined it and refined it. So they know how they're going to be the best. So what are we trying to solve? What are the problems? Well, 10% of construction claims in the UK are due to incorrect or incomplete information. That's a disgrace. That's just simply getting the job wrong. We've got to be able to do better than that. It costs £2 billion a year in the UK to put those things right, to repair the mistakes that we've made. We do too much work at each stage. We're not thinking about lean, about what we need to do at each point and only that much. And then we recreate the data time after time after time. If you look at building smart, they did this thing, it's the sawtooth, where it shows between the different stages how much information we lose. It's ridiculous what we do. It is incredibly inefficient. So once again, I mentioned before that the government does lots of reports. This was a thing called Coordinated Project Information in the UK. This was how we bring these information types together and standardise specification, drawings, and bills of quantities, the cost model. It works. In fact, a few years later, Sir Michael Latham wrote this report called Constructing the Team. He said everybody should use these standards, these protocols for information. But he called his report Constructing the Team. He said, why in construction do we assemble a team to build a building and then break that team up at the end? Where's the learning? How do we learn how to do things better each time? I'm sure you've all built IKEA furniture, or IKEA, call it IKEA? IKEA, I mean, we call it IKEA. It's really hard doing the first one, isn't it? Because you can never work out where the screws go and how these things fit together, and you make mistakes, but the second one is always a bit quicker. And that's the fundamental principle. If you learn how to do things, the next one's better, and the next one's better again. That's the principle behind constructing the team. Bring team members together and keep them together. Egan came along a little bit later and said you need to bring the client into that because they own the assets. So how can the client become more professional and be part of that information process? Skip on 15 years into 2011, and the current government in the UK said construction is inefficient, we want to save money, but actually we think we can invest in the construction industry and make it very, very good, going back to Francis Ward's view on turning UK construction into a world leader. That came in two major reports then. The first is our low carbon action plan. Like most governments, we have 2020 and 2050 carbon targets, and the built environment contributes just under half of all CO2 in the atmosphere. So we need to do something about improving our buildings, but also we need to do something about our efficiency, and that's where the BIM strategy came in. So these two reports together, these last two, have set the direction for our industry. The government has said, this is the way you must start to work. They are by far the biggest construction client in the UK. They spend around £30 billion a year on buildings. So if your biggest client says do it this way, the industry will start to see how they can actually achieve it. And the government gave us just a few small targets. The first one was that by the end of, by April 2016, all people working on a government project have to work in a 3D collaborative environment. They did not define what that means. Okay, they just said it has to be a 3D collaborative environment. The output of it has to be this thing called COBE. COBE was developed in the United States by the US Army Corps of Engineers. It's a data schema, a data structure that allows you to take the construction data and put it into the asset management tools that the clients have. So it's just a data structure. Our chief construction advisor at the time said, all you need to do to use BIM is use Excel. Well, yeah, not quite. But the output is in Excel. And then lastly, you've got to do all of that and save 20% in cost as well. But they gave us until 2016 to do this. That was okay. If we look at what that means, this is called the View-Richards implementation wedge, and it takes us through different levels of BIM. So level 0 is using 2D CAD, just lines and arcs. Level 1 is where we're starting to get into a little bit of structured data. It might be in 2D or 3D. Our target for 2016 is that red line. And that's where all of the different disciplines are working in 3D models with attached information, that's BIM, and coordinating those models on a regular basis. If we do that, we improve between the different data sets. So our target for April 2016 is that red line. Now, The next bit we need to think about is where are the savings going to be made? And it's this concept of BIM, BAM, boom. If we look at the cost factors of construction, the actual design and the cost of the designers is a factor of 1. Cost of building it is about 10 times that, a factor of 10. And what we tend to find with traditional clients is they'll go to the design team and say, can you do it for half the price? And they'll go to the constructors and say, can you get those cheaper materials? But actually, you're not going to save much money in the capital phase. In fact, cutting on the design fee is probably the wrong thing to do. Because if you design it well and you build it well, the operational cost at 100 is where you can save an absolute fortune by making sure you have the right materials, the right products, life cycle costing to understand where investment should be made. And this is the whole concept that the government's going for, looking at how we make savings, not just in the construction phase, but in the operational phase of the building as well. They brought this thing in called government soft landings. So government soft landings is where we document the building that's built, hand it over, and then we monitor the performance and learn for the next building, and the next building, and the next. It's an improvement cycle. We test the behaviour of the building. And rather scary, there's a project called Carbon Buzz in the UK, and what we found is the difference between the design performance of a building and the in-use performance of a building is about 30%. So if we're using our building code to achieve our carbon targets, the government's carbon targets, what are we going to do? We've either got to increase the performance requirements by 30%, or we've got to narrow that gap, or a bit of both. So there's a huge gap at the minute between the actual, well, the design and the actual. So this is COBE, where you take information from design into building and then push it through into the operational phases, into the operational management tools, the asset management tools of the client's portfolio. Now this is a really important drawing. The little red line there shows you how the data matures through the life of the project. The dotted line is where you start building stuff. So at the start you don't know anything about the data, and eventually you get to 100% through these things called COBE data drops. And what we're doing is defining the building at each of these stages to test whether we've got what we expect. And then you get data drop 5, which is the as-built information, and all the ends are where you do further work through the building, through the life of the building. So we've got lots of data drops. We're checking the building as we go. What does the data look like? It looks like this. This is a pretty normal COBE spreadsheet. It is full of all of the geometry and the data about the building. Nobody can put all of these together. We've done lots of tests. We can populate lots of it, but nobody has yet populated this spreadsheet to 100%. That's one of the challenges of moving forward with BIM. We're getting close. We are getting close. If you try to do that just with geometry, you'd only get half of the data. So the information is really critical. Hate to say it, but specification is part of our future world. So let's get back to this team, this Formula One team. The other thing about Formula One is that as that car is flying around the track, they know exactly what it's doing. They've got telemetry. So how do we test the in-use of a car? We put sensors on every part of the car. How do we test the in-use of the building? We use the same sort of technology. The Internet of Things, where we actually start linking all the devices together. These are things you've probably seen before, so you can control your heating remotely, or building management systems for larger buildings, etc. You can control it all on your iPhone. You'll be able to turn the cooker on in the future. We can do it now, actually, as you start adding all the appliances to the Internet of Things as well. This is how we're going to start doing the same with buildings. But we need to attach data to all of these objects. But it's not just about the technology, it's about people. It's about the whole process and how we change that. So, the first thing the government has started doing is project bank accounts. In the UK, lots of building product manufacturers were going bust. Not because they weren't profitable, it's because they weren't being paid on time. The main contractors were being paid by the client, but then holding on to the money. One of the main contractors in the UK was paying their suppliers on 120 days terms. That's disgraceful. The government said this is a bad thing. Cash flow is really important to lots of small businesses. So what we're going to do is we're going to put all the money into a project bank account, and rather than paying the main contractor, we're going to put it into a project bank account. The main contractor get paid for their bits, the product suppliers get paid for their bits, the subcontractors get paid for their bits directly out of that project bank account. Ooh, scary, because what does that do to the cash flow and to the balance sheet of the major contractors? That changes things. Project insurance. One of the issues on BIM, I'm sure those of you who've been doing this will come across the insurers saying, oh no, you can't share that information. And we don't want you sharing that information, because if you get that wrong, people will see you got it wrong. It's the wrong mindset. If you share information, others will see you got it wrong before the mistake becomes an issue. So you can actually improve as a team. So moving towards project insurance and then contracts that do the same. It's about the project, not about the individual teams. And lastly, the revised plans of work, changing the whole process. For once our whole industry came together and agreed, we need to restructure the whole process. I'll show you that in a minute. So, what support has the government been providing to the industry? How do you help an industry go from one place to another? Well, firstly, they built this thing called the BIM task group. And on there, and this is a free site, anybody can go up and have a look. There is a huge amount of resources up there, so you can find out all the learning that you need, all of the information, the pilot projects, to see what's been done. And I've got the website for you right at the end of this presentation, so you'll be able to write it down. The task group, we've got pilot projects and learning statements. We've got BIM hubs in each of the regions, so support networks. People can get together and talk about their experiences, and also learning a standard curriculum for BIM. In fact, we're just about to do the second version of that one, because we've learned what works and what doesn't. We've put lots of protocols in place. So we've got the CIC protocol for BIM. I've already mentioned soft landings, plans of work I'm going to talk to, and Uniclass, which is our classification system in the UK, developing the classification system. In terms of standards, these are PAS standards, so once again they're free. You can go to the British Standards site and download these standards. There's a link on the BIM Task Group website if you want to do that. So the first one is about the construction phase, the second one is all about the operational phase, and that first one is now being developed as an ISO standard. We're looking at how we can start integrating this across other nations. You'll see that in number 2. We've turned COBE into a full British standard, and that will get released in 2 weeks' time. And really interesting one, this last one here, data security. The government has finally realised, hold on, in BIM there's going to be all this data which could be potentially useful to bad people. How are you going to protect the security of some of that data? So we've now got to develop a standard on data security as well. Then we've got some rather more mundane standards. The reality is the first 4 of these, I chair the British Standards BIM Committee, so I know these quite well. The first 4 are not useful for most people. Well, the 2D standards one is, but that's all had. The really interesting ones are these 2. We've developed a standard for assemblies. What is an assembly? What's a product? That was a lively debate, I can tell you. And product declarations. Across Europe, we have the requirement for CE marking. So we've identified what all the product's properties are that are required for product declarations. And that standard will be out in about 4 months' time. Then we've got the Building Smart Standards, IFCs, we all know and love. Personally, I'm a little bit unsure about the other 2, the Data Dictionary and IDM. It's not that they're not needed, they are absolutely vital. I just don't think we're making good enough progress on these, on IFD and Data Dictionary and on IDM. IFC needs further work because the property sets in IFC are not rich enough. But they really must get hold of the Data Dictionary. Why? Because if we don't understand the meaning of words, we get very, very confused. So we've got Lisa talking about pi, and Homer thinks it's something completely different. The Data Dictionary is absolutely vital. So, pilot projects. The first one we did a few years ago was a prison. The reason they chose a prison is that the customers in there can't complain. And it's relatively repetitive, was the real reason. So how did it go? Well, this was it did a full mapping of the processes up at the top, and they modeled it all. 29 different models. When people talk about single model, anybody really seen a single model? No, 29 different models all linked together. And they did this so well. Because it was a pilot project, they ran both the traditional process and the BIM process side by side. And before they even got to the tender stage, they ditched the traditional process because it took too long. The BIM process was so much quicker. That project delivered savings of 18% in its construction cost. That was the first of the pilot project. It was astonishing. Now that was slightly easy because it was repetitive. The schools that they've done have delivered savings straight away of 12%. So these are real savings on construction costs. If you are a government that's spending £30 billion, can't really do the math, so I'm going to say 10%, that's £3 billion extra you've got in your pocket. That makes a huge difference to any organisation. So how's this been received? Well, this is Patrick McLeamy, he's Chief Executive HOK, he also leads Building Smart, and Patrick thinks it's great. He can see that the government here have done a good job and they are moving things forward. We've also then got Phil Bernstein from Autodesk, and he thinks this is done well as well. So all in all, that first stage of getting us forward to 2016, we seem to be heading in the right direction. I'm going to put a counter to this when I show you our surveys on the industry. But anyway, let's move on because the government has. They decided, oh, you've done really well with 2016, we're going to set some better targets for you for 2025. So they put this thing forward, it's the Construction 2025 strategy, also known as Digital Built Britain. We are turning it into a digital industry. So we're now going beyond that red line and we're moving into file sharing, so single hosted environments. That's our target. But it's not just about the technology, it's about these 4 themes. Sustainability, remember the Carbon Action Plan? How are we going to make this more sustainable? What about growth? Because we want to still support growth of an economy. How do we do that? Yeah, we've got the smart technology still there as one of the 4 areas, but people. How do we change culture? Because that's what we've got to do. So in our level 3 work, we're looking at all of these 4 streams to see how can we change the industry. We've also given us 4 targets, 4 simple objectives. This looks really easy, doesn't it? All we've got to do by 2025 is save a third of the cost now, not 20%. They thought 20% was obviously very easy, so we're now going to turn it to a third. Oh, by the way, you've got to deliver the buildings in half the time as well. You need to reduce the carbon in buildings by half. And in the UK, we've got a big issue with imports and exports of construction products. We import £12 billion more construction products than we export. So we want to try and halve that as well. How do you go about doing that? These are astonishing targets for 2025. They really are, in business terms, they are stretch targets. You cannot do it with an industry like the one we have today. It is simply not possible. So this is the driver for us to change our industry. Why do we need to change? Well, for a start, because of this. We design things badly so that we have to cut plasterboard. We've got to then we'll make it, cut it, and then throw it away. That's a complete waste. Lots of other things end up in a skip or a tip and get thrown away. That's bad for cost, it's bad for carbon. We've got to turn it into an industrial process where we start thinking about how can we get better quality, better time and cost management. And that means turning it into an off-site based industry where you can still do bespoke work on site, but its fundamental structure is done a different way. As Bob says, the times are changing. But it's not now just about our government, it's what's happening across Europe. Firstly, standards. We're currently working at European level on a SEN working committee for the BIM strategy. And there's also above that same committee, there's an ISO committee working at ISO level to create global standards. If we are going to get this to work, we have to recognise our customers work around the world. And that means organisations like mine and Bips have to work together to standardise the information structures so that we can be using those information structures wherever around the world. It means that you will be able to do your job wherever you want to go. So European governments got together. It started at the end of last year, and the output has been complete changes in the early part of this year. All of these countries were involved, so there we go, Denmark has been involved. If you look at a map, it looks like that. Some curiosities. Why doesn't Switzerland ever get involved? But also, the one that's missing off there is Singapore. Because Singapore were involved for some reason. Last time I looked, they weren't in Europe. But anyway, they were around that table as well. And what have they done? They have all agreed now to using that implementation wedge. They are going to target their BIM requirements. So Germany have just done it, France are doing it. So the big economies have realised this is a sensible way forward. Personally, I think it's when the UK government said, we save 12% on our buildings. I think that was quite a dry one. So underlying all of this, the world is changing. But it still, for me, comes back to what about the people in the industry? We've been surveying the industry for the last 5 years, or doing the 5th one at the moment, to look at change and adoption. And what we're finding is bit by bit, people are moving. 4 years ago, just under half of our industry had never heard of BIM. Now it's just 6% have not heard of it. Where have they been? So if we look at Europe, this is an Autodesk survey looking at adoption and the requirements. Finland right about at the top there. It's amazing going to Finland and seeing what they're doing. UK not doing too badly. Denmark's there, it's ahead of France and Germany, so you're doing well. I think this is 2 years old, we need another version of this one. And then lastly, we've done this global survey. I think I heard Gunnar mention that. I picked those bits out. You'll see the UK's behind in adoption here, which I find really odd. Does that mean that we're rather reserved and we're just saying, yes, we're doing it, but we don't want to say too much? Or is it really these other countries are well ahead? I'd like to think it's that they're well ahead, and we've got a lot more work to do. We want to try and run this survey, a standard survey across lots of countries, so we can chart that progress and see how all these different countries are performing. But what about the information? ISO actually provides them the definition of BIM. That's really good, very kind of them, from 2010. And that's the key statement for me. It's not about the technology, it's about how you make better decisions, how you improve decision making in construction to improve the process. We wanted to extend that definition because we thought it was a little bit light, so we added all of this. And we think these are some of the important points. It's a rich information model from multiple sources. It's from inception through to recycling as well. And critically, it's not just about the geometry. You can have all sorts of information attached on a rigorous, well-structured information model. But why do we do it? Well, it's about competitive advantage. If you have the right information, the right knowledge, at the right time, you can do amazing things. If you apply the information, it provides you with competitive advantage. You can be better than your competitors. Now, somebody who knows about that is this chap, Bill Gates. And once again, in there, he's got this great statement. How you gather, manage, and use information will determine whether you win or lose. One of the big supermarkets in the UK, Sainsbury's, their chief exec, who's just left after 10 years, he went to the sales office of one of his colleagues, and he had photographs on the wall, and some of them with red crosses through. Justin King said to him, who are these people? He said, they're my competitors. They are trying to take the food off my table. And what he was trying to do was take them out of their job because he wanted to be better, he wanted to eat. And that's what we've all got to do as well. And information provides you with that advantage. So how do we bring it all together? Information changes through the life of the project. The process map is really important, and the scope of that data as well. And it's not just about geometry. Specification is vital, because that's where you get the understanding of what things mean. but also the environmental and sustainable data. So I'm going to talk about this map and the job book, which it tells you what you should be doing, classifications, specifications, product information, how all of these fit together, and this is how they fit together. In the specification, which for us is called MBS Create, we have lots of guidance, and it helps you make those decisions against every specification system or element. It helps you make the decisions. Now, they are organised by classification. For us, it's Uniclass 2. Classification is really important for humans, not really important for computers. But for humans, knowing where to find things is really important. It doesn't matter if you use one classification or another. What matters is you use a really good classification system. The process management is there as well. The plan of work tells you what type of information you need at each stage, those Kobe drops. So what information do I need as this project starts to develop? Clearly all of this has to link to a geometry model. That might be Revit, ArchiCAD, Tekla, whatever it would be. And they have to come back to product objects. The geometry models use these objects to assemble the building. And also, you need access to standards, regulations, etc. to make sure you are compliant. So that's the model of information we're starting to look at. If we look at process management, this is the plan of work. It's a circle. It's not a linear process anymore, because it goes through inception and right way back round. And as I mentioned before, what we did in the UK was define the stages and get all of the disciplines to agree on the stages of this plan of work to define what information is required. And what we've also done is put up another free tool which identifies for each stage what level of information, level of detail everybody is contracted to doing, and it uses the classification system on the left-hand side and the stages over the top to define what everybody does. In the specification tool, we have lots of products out there. This is our spec tool Create. The top bit is the process map, so it goes from outline specs to performance and then the detailed specifications. You have libraries, which are our libraries, or it could be our customers' libraries. And in the middle, this is where you edit the systems and the elements, but always supported by guidance. And in the guidance, you have links to standards, regulation, product information. But it's just a BIM tool in its own right. It is an object model in its own right, so we can see how all these different things link together. Then we have the product information. Once again, lots of different types, but the key one for us here is this one, which is the National BIM Library. In here you'll find generic objects, so there's hundreds, something like 800 generic objects, all fully populated with property sets that are needed to populate Kobe. But you'll also find lots of manufacturer objects as well, also with all of the property sets to populate Kobe. And it's real objects that can be used on real buildings. So this was done by HOK for us using National BIM Library objects. But somehow then we have to link it together. So I'm using Revit for this one. There's a Revit model. Typically what an architect will do, or engineer, surveyor, they'll build a geometry model. And what we've done with the objects is build links into all the specification codes. So that once you've built your model, you can click the plugin to Revit, and it will automatically build the specification and link the objects together, the spec objects and the geometry objects. So then you can code up straight away all of the objects in the geometry model. If you then start editing any of these or changing them, you've just broken the link between the specification and the geometry. So we run a little report whenever, well, you run a report when you want to, and it highlights where there's a problem. So that problem of incomplete or incorrect information disappears. You can then go and rebuild the links, and all of a sudden your model's back together again. You keep working on the model, and what you now need is some more objects to bring into your geometry model. Because you've linked the geometry and the spec together, you can now open the National BIM Library in Revit, or ArchiCAD, or whichever tool you're using. You can also get the manufacturer objects and drag them straight in. And because you've linked the specification with all the guidance, you can look at the guidance of MBS, and that's about 7 A4 binders full of guidance and links. You can do it inside Revit. You get access to British standards in there, so inside your design tool you've got access to all this knowledge. But not just that, because inside NBS Create, the user can build their own knowledge base. You can link your own knowledge inside Revit as well. So, how did we do? Well, the industry likes it so much, we won an award. First time in 40 years we won an award. We won the Digital Built Britain Award, the first time it had been awarded. Remember that links to the government strategy? Because this is exactly what the government was looking for. And the handsome one, second left. So just a last bit to show you. We're also working on carbon and cost modelling and how we attach carbon and cost. Now the next 3 slides I'm going to show you, get your cameras out because this will not be in the version that goes public. But I thought I'd just show you what we've been up to. For all of those data drops, we're having to develop data structures. Data structures that you may have come across the levels of detail from the American Institute of Architects. But what we've been doing is developing the levels of detail for the government in a competition to actually detail up all of the information and property set requirements for each of those COBE drops. Nobody's done this. I think this is actually what becomes IDM. And what you'll see here is this is a really simple interface with a project, so we capture data on projects. If we go into the projects, we can see across all of the different data, the elements, and it can be spaces, what level of detail we have, and this new concept of level of information. So if you go and have a look at any object, what we find is across each of the levels of detail, what it means in geometry terms, but also what it means in terms of property sets and information. So we've done a huge amount of work. The final project will be delivered in April next year, and it will have 6,000 product templates at each of those level of information, level of detail stages. And once again, that will be free, because it's a government-funded project, it will be free to wear. So watch out for that one. So, summary, finally tying it all up. The times, as Bob says, they are a-changing. BIM is not the enabler, BIM is not the target. Sorry, BIM is the enabler, it's not the target. The objective is to improve the process. And that process does not create standard architecture. Architecture will always be different. The process is the thing we standardize. Our customers will operate across national boundaries, and we will work with organisations like Bips to ensure that we standardise the information structures underneath. But most of all, it's not about technology, it's about people. In the UK, we have to do this by 2016, that's our target. There are ambitious targets then for 2025. And this is not going to be about just merely evolving an industry. It is revolution. Everybody in the industry in the UK has got a simple choice. Rather like Kodak, adapt, adopt. If you don't, you will be like Kodak. Finishing off, scientists argue there is no such thing, no concept as an irresistible force or an immovable object. Those things do not exist. But actually, I think we're moving to some very irresistible objects. Thank you very much.